Let's continue with multiplication of complex numbers. So we have two kinds of multiplication. The first one is scalar multiplication. And scalar multiplication, the scale there means scaling up or down. You could think of it as kind of blowing up or down one number. For instance, when we say 7 times 100, we blow it up 7 times, or 1/7 times 100, we blow it down, I guess. At any rate, whenever you see scalar in math, it's going to be multiplication, and it's going to be multiplication by one value of whatever thing you're multiplying. Okay, so here we are with a real number k multiplying a complex number a plus bi. We distribute the k. No real surprise there. We could also multiply by a complex number, just a scalar, so it's only in this case the imaginary component of the complex number. And that involves right here something interesting. We have I times I. Think of it as though it were any other constant or variable, and that gives us I squared. And what does I squared give us? Well, we recall that it's -1. So in standard form, this is what we wind up with. Now, I don't advocate memorizing this as though it were a formula. You just do it when you get to it. You remember the method. Okay, so here's a multiplication problem. Oh, what did I do here? I rearranged so that I had the real component of the imaginary number first. That's not really necessary, but it commutes, of course. Okay. Holy moly, I have an error there, don't I? That should say positive 56i and negative 16i squared. Yikes. Well, if I had it correct, it would have been that. Let's pay no attention to the man behind the curtain and go on to multiply two complex numbers. We are going to FOIL these as though they were any other binomial. So here we have the result of multiplying a, the first real component, by everything in the second complex number, and then bi, the imaginary component, by the components of the second real number. I'm going to rearrange so that I have now the real components on the left and the imaginary components on the right, because after all, this I squared here is going to turn plus bdi squared into minus bd, and on the right I factor out the I, and that gives me the imaginary component. There we go. And this is now in standard form with the real component on the left plus the imaginary component on the right. An example. I sure hope I got this one right. Did I? I persuade myself that I did. Okay, I haven't rearranged anything yet. I still have first outside, inside last. Check out what's going to happen to that last one. Well, now I've rearranged things so that I have all of the real components left on the left and the imaginary components on the right. That's in preparation for the standard form after I simplify this. Plus 36, and then you see also our final result. And we can do this in the calculator. Darn good thing. Now, there's one extremely important special case when it comes to multiplying complex numbers, and you must know this one. That's a plus something, and then I'm multiplying by its conjugate, a minus bi. So this is called a conjugate pair. We've seen something similar to this when we had multiplying of square roots. at any rate, what I'm going to have here is the same as if I had x plus y times x minus y. So I have FOILed it here, and you can see that I have two terms that are going to go away, and shazam, there's my very special case. When I multiplied these two numbers that are conjugates of each other, my result is a squared plus b squared. Now, here we see another one, x squared plus b squared. The flip side of this is that it factors into a conjugate pair. This, we can't factor that in the reals. We need to go into complex numbers to get factors. We can see from the x squared that there need to be two linear factors, but those linear factors now are not real numbers. We can only factor this in complex numbers. This is a form that you need to recognize and use without really thinking about it. Okay, so how are we going to use it? Well, let's see. Can we factor this? If this is equal to 0, this is now an equation that we can solve rather than a function. Okay, so x squared plus 25 is equal to 0. What are the zeros of this? They're not real numbers. These are going to be complex zeros. Because why? Well, we can't take the square root of both sides here, at least not in the real numbers, but we can take the square root, we can factor it in the complex numbers, and then, as we would with any other pair of linear factors that multiply to be 0, one or both of those has got to be 0, and we can see what the zeros themselves are. And you probably recognize this form, or have some recollection of it, from the quadratic formula. That's where we're going to see most of it. That's the end of our session on multiplication.